present about Fibonacci sequence.
Hi, today I want to show you all how Fibonacci sequence works.
So, the sequence usually refers to a set of numbers that starts with 0, 1, 2, 3, 5, 8, 13, 21 and so on till infinity. So,
Fibonacci sequence is actually a series of numbers made by summing up two numbers before it.
Many people skip the number 0 because it doesn't mean anything or it is not important. The Fibonacci sequence, of course, the name Fibonacci refers to its creator, Fibonacci, or also known as Pisa, or also known as Leonardo Pisano in Italy. So these mathematicians had invented the Fibonacci sequence when he was in a contest during his emperor's birthday. So he created the sequence to win the contest, to calculate how many population of rabbit that he can count throughout several months.
Here. Then, when we make a square with those series of numbers as a wheel, we will get a nice spiral. And let me show you how it done.
Sequence is very significant to be applied in our life, in our daily routine, and also the universal, and also can be applied to universally to the world.
Fibonacci sequence can be found in all parts of the nature, especially plants. As you can see here, Fibonacci sequence has influenced the part of the branching system of this plant. As you can see in the lower part, it has only one branches, and as we go further, the branches has increases into 2, and as we go further, the branches has become 3 and then 5.
If we draw horizontal lines through the axials, we can detect obvious stages of development in the plants. The main stem produces branch shoots at the beginning of each stage. Branch shoots rest during the first 2 stages, then produce new branch shoots at the beginning of each subsequent stage. The same law applies to all branches. This design provides the best physical accommodation for the number of branches while maximizing sun exposure.
Besides, Fibonacci number also can be found in other parts of the plant such as flower. Let me show you some examples.
Most of the flowers exhibit Fibonacci number in their number of petals. This is a solid proof to show how huge the influence of the Fibonacci numbers in the nature. Fibonacci numbers allows flowers to grow in proper manner and beautify the environment. There are 1 petal of flowers, 2 petal of flowers which are not common but exist, 3 petal flowers which are common, and literally almost hundreds of 5 petal flowers exist.
Hey, come on here. Do you know, believe it or not, pineapple also obey the rules of Fibonacci sequence. Can you see the patterns on its skins? You can see that it has a shape of spirals by Fibonacci sequence. It's also not only 1 but 1, 2, 3 and 4, and it's continue until it's back. It also has the Fibonacci sequence in a backward shape. 1, 2, 3 and 4.
Pineapples also can be one of the best examples for Fibonacci sequence. Pineapple scales are patterned into spirals, and because they are roughly hexagonal in shape, 3 distant sets of spirals may be observed. In this example, one of set of 8 parallel spirals ascend at a shallow angle to the right. A second set of 13 parallel spirals ascends more steeply to the left. And the third set of 21 parallel spirals ascends very steeply to the right. The number of sets of spirals can be different from other pineapples, for instance 5, 8 and 30.
Cabbage also has 3 petals, which is a Fibonacci number. Have a watch.
Cauliflower looks and tastes like a cross between broccoli and cauliflower. Each floret is big and is an identical but smaller version of the whole thing, and this makes the spirals easy to see. Let's count the spirals with me. 1, 2, 3, 4, 5. Yeah, it's proven that cauliflower has 5 number of spiral, which is one of the Fibonacci numbers.
Can be found in our nature and as well in animals. For instance, in the bees. Okay, let's say this, the small one is female bees and the bigger one is male bees. Okay.
The single parent for male bee is female bee. After that, the parents for female bee are a pair of bees. Consequence, a pair of bees came from another female bee and pair of bees. That pair of bees actually came from another pair of bees and female bee, while male bee came from female bee. It is follows as shown by numbers of bees that are 1, 1, 2, 3, 5 and so on.
Furthermore, we can see the Fibonacci sequence in such animals, and for example, rabbits or bunnies breeding, and say we can conclude further. Dragon will be discussed later.
Let's assume rabbit never die. Blue rabbit stands for male rabbit, while green rabbit stands for female rabbit. While rabbits spawn is getting mature after 1 month, a pair of rabbit A is matched up. After a month, they mature and ready to deliver one more pair of rabbit B. Rabbit A will continue to deliver one more rabbit to be paired and produce new rabbits. And hence, the new rabbits is we call rabbit C, while rabbit B will stay one generation as it is still getting matured for 1 month. In the third month, rabbits A produce rabbits B, and rabbit C still stay on one generation. At that time, rabbits B already matured. It produced a new pair of rabbit, and the new rabbits is called rabbits E.
Okay, for the conclusion about the Fibonacci sequence, we can also take a look for the spiral golden in the shell of snail, and for the scratch side of the snail, we can see the perfect shape of spiral, and that's it. The shape of spiral golden also same with the shape of the side of snail shell. Okay, thank you.
So what is most important in Fibonacci sequence is the number. It has a unique number that is same as pi, where pi is 3.142, while Fibonacci sequence, the golden ratios, shows a number that approximately will reach to 1.618.
The most obvious example in golden ratio, which is 1.618, can be seen in human body.
The constant, superior design number of mathematics.
The ratio between the distance of fingers to the elbow and the wrist to the elbow is 1.618. The ratio between ankle to the knee and from the knee to the waist is 1.618. The ratio between the shoulder line to the top of the head and the chin to the top of the head is 1.618. The ratio between the waist to the top of the head and the shoulder line to the top of the head is 1.618. The amazing fact is almost all part of human body satisfy the golden ratio. To summarize, we can see Fibonacci sequence in animals, human body and plant. We can see the example we have shown just now. We also show the golden ratio in human body. Okay, can you discover more examples?